Hi students, in this video, let's discuss the most important algebraic identities. Let's get started. A plus b the whole square is equal to a square plus 2ab plus b square. Now how do we do this? We just multiply a plus b with a plus b. Now you can do this in two ways. Now one way would be you treat a plus b as one unit and you give it to a and b. So you get a plus b into a plus, because you have a plus over here, a plus b into b, right? And then you open this bracket, so this becomes a square plus ba plus ab plus b square, and that is equal to a square plus 2ab plus b square, which is what we have over here. All right, now another way of opening the bracket is like this: a plus b into a plus b. That's what we are trying to do, right? Now let's give this a to here. So we have a into a, which is a square. Then I give this a over here. So that's a b, right? Now then I have b into a. So that's plus b into a plus b into b, which is b square. So this is also one way of opening the bracket. All right. Now let's see a few more and then I'll tell you an interesting way with which you can initially remember these by heart, right? So that will help you memorize it. But with practice, automatically you will start remembering these identities. All right, let's proceed. The next identity is a minus b the whole square, which is equal to a square minus 2ab plus b square. All right, so over here also you can check it out by multiplying a minus b with a minus b. All right, now the next one would be a plus b the whole cube, which is equal to a cube plus b cube plus 3ab into a plus b. Now over here you can check it out by doing a plus b into a plus b into a plus b. So first you simplify this part and then you multiply that with a plus b. So you'll get this part. Now another one would be a minus b the whole cube. That's a cube minus b cube minus 3ab into a minus b. Now I'll tell you a way to remember these four identities. Now from these two identities you can get two more: a cube plus b cube and a cube minus b cube, right? Over here you have a cube plus b cube. So you take everything else to the left hand side and you will get this expression over here. That is a cube plus b cube is a plus b into a square plus b square minus ab. Remember, it's a minus over here, though you have a plus over here. All right, and over here you have a cube minus b cube. You take everything else to the left hand side and you will get a cube minus b cube is equal to a minus b into a square plus b square plus ab, which is this equation over here. All right, now let's keep these aside and I'll show you a trick to remember these. Now the trick involves the Pascal's triangle. Now first let's see how to construct the Pascal's triangle. We start with 1 and then we have 1 1, and in the edges you will always have 1. So in the third row also you have 1 and 1 in the ends, and in the middle it's the sum of these two. So 1 plus 1 is equal to 2. All right, the next row also will have 1 and 1 at the ends, and this term would be 1 plus 2, which is 3, and this term is 2 plus 1, which is 3. All right, now an important thing to remember is a plus b the whole square will have 2 plus 1, that is 3 terms in its expansion. So you can see that we have 1 2 3 terms. Similarly, a plus b the whole cube will have 3 plus 1, that is 4 terms in the expansion. So over here you can see 1 2 3 and 4. So there are 4 terms. All right, now let's proceed. Now we know that a plus b the whole square will have 3 terms in the expansion. So let's take the row in the Pascal's triangle which has 3 terms. So that's this row, right? So over here we have 3 terms, therefore it correlates with this row in the Pascal's triangle. And a plus b the whole cube or a minus b the whole cube have 4 terms, so that correlates with this row in the Pascal's triangle where we have 1 2 3 4 terms. All right, now these are nothing but the coefficients of the expansion. So let's try to find out a plus b the whole square. Now we know that it has 3 terms, right? So let's mark 3 positions. Now let's use 1 2 and 1 as the coefficients. So I have 1 over here, 2 over here and 1 over here. Now I start with a to the highest power, which is 2. So I have a square over here. In the next term, I reduce the power of a by 1 and increase the power of b by 1. So over here there is 0 power of b. So b goes from 0 to 1 and a's power goes from 2 to 1, right? So a's power goes from 2 to 1 and b's power goes from 0 to 1. So over here I have a to the power 1 and b to the power 1. Now over here again a's power goes from 1 to 0 and b's power goes from 1 to 2. So I have a to the power 0 and I don't need to write that because a to the power 0 is 1 and b to the power 2. So I have b square over here. Alright, now because I have a plus over here, I just need to fill all the places with plus, and this is the expansion of a plus b the whole square. Now let's do a minus b the whole square. The terms are the same. The only difference is that when I have a minus over here, I need to alternate between plus and minus. So I start with a plus. So I have a plus over here and a minus over here and a plus over here. So this is the expansion of a minus b the whole square, which is a square minus 2ab plus b square, which is what we have over here. Alright, now let's do a plus b the whole cube. Again, there are 4 terms involved. So let me mark 4 positions. Now let me use 1, 3, 3 and 1 as the coefficients. Alright, now the first term has the highest power of a, which is a cube. So that's a cube over here. Then I reduce the power of a by 1 and increase the power of b by 1. So over here I have a square b. Again, I reduce the power of a by 1 and increase the power of b by 1. So that's a b square. And I reduce the power of a by 1 and increase the power of b by 1. I have b cube over here. Now because I have plus over here, let's fill everywhere with plus. So this is the full form or the expansion of a plus b the whole cube. That's the same thing that we got over here. This is a cube plus b cube plus 3a square b plus 3ab square, right? Which is what we have over here. Alright, now let's do a minus b the whole cube. That would be the same thing, same expressions. Only thing is that you need to alternate between plus and minus. So plus over here, minus over here, plus over here and minus over here. Alright, now this is just to get started with, right? So it helps you think about it in a better manner. But with practice, you will easily be able to remember these identities by heart. Now from these two, we can derive these two also, right? Over here, let's do it over here. I have a cube and I have b cube, right? Let's take this to the other side. So I get a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b, right? Now let me take a plus b as a common factor out. So that's a plus b into, over here I'm left with a plus b the whole square, and over here I'm left with minus 3ab, right? Now what is the simplification of this? Let me write that over here for the purpose of space. I have a plus b into a plus b the whole square, which is a square plus b square plus 2ab minus 3ab, right? So that gives me a plus b into a square plus b square minus ab, which is this equation over here. Similarly, a cube minus b cube will be a minus b into a square plus b square plus ab. Now if you just put your mind to it, you can easily by heart these. Now it's helpful to know this and have them ready at your fingertip. Alright, now let's see some more algebraic identities. The next important identity is a square minus b square, can also be written as a minus b into a plus b. Alright, now let me relate this with geometry. Now over here I have a square of side a and I have another square of side b inside this square. Now you can refer the section in geometry. The area of a square of side a is a square. So this whole part would be a square and this part would be b square, because this square is of side b. Now a square minus b square then would be this shaded region, right? Alright, now let's see how we can relate this with geometry. Now I join these 2 points over here. Now I have a trapezium over here, which is just a special type of shape which you can refer more about in the geometry section. Now I have this part over here. I rotate it and I place it like this over here. Alright, now the initial area which we shaded is nothing but this area itself, because we just realigned it, right? Now you can see that this much over here is a, because we said that this square is of side A and this is B. So therefore this much over here will be equal to A minus B, right? Now we know that this much is equal to A because that's part of this square, and this over here is equal to B, right? All right, so because we took it from here, right? Remember, it was placed like this over here, and this is equal to B. That's what we have over here now. So this is A and this is B. So this side over here will be A plus B. So we are getting a rectangle of length A plus B and width A minus B, and we know that the area of a rectangle is length into breadth. You can see that in the section where we deal with rectangles in geometry. Now over here we get that this shaded area is equal to A plus B into A minus B. So geometrically we have seen that A square minus B square is equal to A plus B into A minus B. Now again, let me repeat, this is just to get you started with. Once you use this a few times, you will easily be able to remember these identities. Now a few more important identities, let me list them over here. So x plus A into x plus B is equal to x square plus A plus B into x plus AB. Now we will use this where we deal with quadratic equations. You can see this in the higher concept algebra section where we deal with quadratic equations. We'll be using this. Now two more over here, A plus B plus C the whole square. Let's try to remember it using the pattern. That's A square plus B square plus C square plus 2AB, and instead of A you put B, you get B over here. Instead of B you put C, so you get BC over here. And again, instead of B you put C, and instead of C you put A to get 2CA. So what we're doing is, that's like cyclic nature. A, you have A over here, you have B over here, and C over here. So over here we have AB, then over here wherever A is you will put B. So over here we had A, so over here we get B, and wherever we had B we put C. So over here we had B, we get C over here. So over here we have 2BC. Similarly, wherever we have C we put A. So 2BC becomes 2CA. So A plus B plus C the whole square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Alright, and what about A cube plus B cube plus C cube minus 3ABC? That's equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Now it will be helpful in solving questions if you know these identities.